Hello all and welcome to this, our wonderful and outstandingly exciting lesson on applying function notation. Yes, I know, function notation. Actually, it's incredibly important. So, those of you who are being educated, or at least attending my lessons, that is the work I'd very much like you to do, and it slightly differs from the work guide. Good news! Don't do question 8 or 9. Those of you who are watching from internet land and have nothing better to do on a Friday evening, hey, welcome. Let's make a start. So, let's do a quick recap as we normally do. This chapter is probably so important I can't tell you, right? Those of you who are in Australia and doing methods 1 and 2 and going on to methods 3 and 4, functions, and more functions, I cannot tell you how important it is. And again, I will reiterate that when you have a function, if you have f colon, let's do real mapped onto real of a function of x is equal to x squared, this is function notation. For SACs, for exams, for absolutely everything you do, please make sure that you write stuff in function notation. If you have some sort of a restricted domain, something from like these lines, again, function of x is equal to x squared plus 7, for example, this is all incredibly important. And as I say over and over again, reading this function is so important. Remember, this here is my domain. Those are the x values that are possible in my function, or those are the x values I want to go into my function. This is just mumbo jumbo. We write it. Thank you very much. University, you can sort it out for everyone else. And this is my actual function. This is the relation. This is the information that says, well, x and function of x. Also really important to remember that f of x and y are interchangeable. Really important. I'm going to come back onto this in a second. But domain and range are the key to actually doing really well in methods. One last thing I need to say to you here is, with straight line graphs, please remember that if you have a straight line graph, if the domain is not restricted, then your domain will be all real values. There's generally no reason why a straight line graph wouldn't have real values as the domain, which would also suggest that my range is also real values. And if we want to write this officially, x is equal to real, and f of x, is a set of real 2. That's the official way of doing it. Now, when you have something like a parabola, if we actually limit the domain, and I'm going to cut some of this off, and we know, for example, that this value here is -1, and this value here in terms of x is 4, then be very careful when you work out the range. The range, you have to remember, is the highest y value and the lowest y value. And with parabolas, huge trick in exams, that my advice to you is always find the turning point, because that will actually help you find the lowest possible value of your range. Also, as I've said today, and I'll say over and over again, in Australia, this is a CAS course. You can use your calculator. Use it to sketch every single graph you are ever given. It'll take you seconds to do it, but it could save you hours and hours later. Now, one of the most important things to remember with any recap is what this means. And as I've just said, if you look at the idea that f of x is equal to y, then what does f of 1 equals 7 mean? Absolutely, for those of you who are screaming at the screen, that is just another way to actually say a coordinate. What do you notice? Well, there is a 1 where there is an x, and there is a 7 where there is a y. And the only thing that has an x and a y in it that, as far as I'm concerned, at this time on a Friday night I can think of, is a coordinate. So that's just another way of saying 1,7. Why am I telling you this stuff? Because it's actually going to come in useful in about 3 seconds time. Alright, so this lesson is basically, and it says there, a review of the methods 1 and 2 textbook. If you have no idea what that means, well, then just accept this as sort of understanding of a wider context for functions. This particular session, we're going to look at practical domains and equations of lines given certain coordinates. Now, what is a practical domain? If, for example, look at this function here, v equals 4/3 pi r cubed. Now, if I remember rightly, that is to find the volume of a sphere. Now, we get so used in maths to having equations given in terms of x and y, that it takes something very, very small to trick us to end up with saying, well, actually, this, if we look at our equation, means we're going to put the value of r into my equation, and out is going to come my value of v. So at all points on my function or in my graph, if we were to plot coordinates, we'd actually be plotting r against v. So I'm now going to delete this and say r, and I'm going to change the y to a value of v. So now the values of r are effectively my domain, and the values of v will be my range. Whenever you don't understand in maths, my advice is just try and see past it. The first thing I notice is the word domain. That's awesome, but this practical domain just is another way of saying think about the question. I mean, ideally you should be doing that with all questions, but in this particular instance, if we're looking at the domain of my function, could we have a domain of minus infinity to infinity? Now, so many people will turn around and go, yeah, sure, absolutely, why not? But think about it. This is for the volume of a sphere. What is the value of r? What does r actually stand for? It stands for the radius of a sphere. Can we have a negative radius? I mean, what, for example, would be r of minus 4b? I mean, that's completely random. While mathematically you could cube minus 4, it makes no sense in a practical situation. So, what's the smallest radius something could have? Well, as far as I'm concerned, the chances are it's going to be 0, right? It doesn't have a radius. And then what would the biggest value of radius ever be? Well, I don't see why it couldn't be infinity. Now, there's a big discussion about whether it should be including 0 or not including 0. As far as I'm concerned, you are looking for a domain that is possible. And it is totally, totally possible to have a 0 radius and a 0 volume. So, if I was marking this, would be perfectly happy to accept my domain, and notice that I put an x, even I'm getting brainwashed, to turn around and say that r is a set of values between 0 and infinity, including 0, but not including infinity. And remember, you cannot include infinity. It has to be a curved bracket because infinity is a concept. It's not an actual number. I love saying that. I learned that when I came to Australia. How exciting. All right, so practical domain. Whenever you're given an equation, think about what it is they're asking you to do. If you have an equation where they're giving you temperature, think about what is the lowest temperature known to man. If they're giving you, I don't know, it's really, really hard, distances. Is it possible in that situation to have a negative distance? Can you go back further than you started? Sometimes you can, sometimes you can't. Practical domain is just looking at values that are practically possible, right? Implied domain, practical domain, maybe, close, sort of, ish, who knows. What about this? Coordinates given in function notation. I've just said that a moment ago. When we have f of 1 equals 7, that is nothing more than saying 1, 7. Right, so we have a question here. What is the question asking and what information are they giving me? Well, the first things first, let's decode this function notation. It's telling me that all real values can go in, and it's mapped onto real values coming out. Right? That's my codomain. That does not mean my range. And we have a function, ax plus b. First thing I think to myself is that is y is equal to ax plus b. X has got to the power of 1. This here is a linear equation, otherwise known as the equation of a straight line. That is exactly the form of a linear equation. It's a straight line. Right, I've been given two of these random pieces of information here. So let me see, I've got f of 1 is equal to 10, and I've got f of 3 is equal to 16. Okay, I'm actually going to write this in coordinate form, 1, 10 and 3, 16. Now, why does that have anything to do with the price of fish? Well, again, the thing with methods is you cannot learn it by chapter and forget about it. It all builds on top of each other. And the best methods kids are those, and I'm going to do a smiley face, the best methods kids who actually build and understand and keep refreshing on the previous chapters. So, two coordinates, straight line. How do I find the straight line given two coordinates? But if you remember, if we have two coordinates, that's 1, 10. That's 3, 16, close the bracket. We can use the fact that the gradient is y2 minus y1 over x2 minus x1. And given the gradient, we can use y minus y1 equals mx minus x1. So let's actually do that. I'm going to find my gradient using the information I've been given. Right, my gradient is going to be given to y2. So I'm going to do 16 minus 10 divided by 3 minus 1. Always important to get those the right way around. So 16 minus 10 is 6, and 3 minus 1 is 3. Sorry, it's not in Muppet, it's 2. And that gives a gradient of 3. So I now have my gradient of 3. So I'm going to use y minus y1 equals mx minus x1. That helps me find the equation of a straight line when I know a gradient, which I do, and I know 1 point. So x1, y1. And because they've given me 2 points to choose from, I'm actually going to use the point 1, 10. I could use 3, 16, it's not going to make any difference. So y minus y1, which is 10, is equal to m, which is 3, x minus x1, which is 1. Right, multiply out the brackets gives me y minus 10 is equal to 3x minus 3, and add 10 to both sides, give me my final equation of y is equal to 3x plus 7. Is that the answer they're looking for? No, it says find the values of a and b. I've sort of run out of room, so I'm just going to write it all over the place. So I would have to formally state that a equals 3 and b equals 7. It's the thought processes that are really important. So number one, what did I look for? I looked to try and see what the equation actually looks like. What is the form of the equation? Is it linear? Is it quadratic? Is it a cubic? Does any of this actually help? What's the point I'm getting to here? Number two, what information have they given me? Have they given me coordinates? If so, why have they given me coordinates? I'll then go on to try and solve using whatever techniques I have. And in this situation, I found my equation by using y2 minus y1 and blah, blah, blah. I could just as easily have put this into my CAS calculator, all right? But again, we'll come back to that later. Finally, for this lesson, right, and the work in this particular chapter deals with 3 very specific types of questions. We have a quadratic function now. So we have a quadratic function, and it's given us f of 3 equals f of minus 5 equals 0, and f of 0 equals minus 45. What? Well, first thing I'm going to do is, this looks confusing. I'm just going to write it out in a slightly longer way. F of 3 equals 0, all right? F of minus 5 is equal to 0, and f of 0 equals minus 45. Right, well, these are basically coordinates, so I'm going to say I've got 3, 0, I've got minus 5, 0, and I've got 0, minus 45. Well, anything that's got a 0 in front of it, that must be an intercept. Is that going to help me? Oh, hold on a moment. Intercepts. These two here, because they have a y value which is equal to 0, they are x-intercepts. Why is this helpful to me? Well, think about the chapter you've just done. You've just done a chapter that deals with nothing more than knowing what the x-intercepts are for a quadratic. It's telling us it's a quadratic. These are intercepts. That means they're the roots of my equation. That means I can write my equation in the form y equals a, x minus b, x minus c. Why? It's given me the 2 intercepts. This is the general form of my equation in intercept form. So that now means I can use that. So I'm going to write it out again just so I've got enough space. X minus b over x minus c. Right. Wow. Y is equal to. So b is going to be minus 5. So that becomes x plus 5. Remember, what goes inside the brackets is the opposite of what we're expecting. X minus c becomes x minus 3. All right, okay, but the problem is I've still got 3 unknowns. I need to know an x value and a y value. There you go. There's my x value and y value, 0 minus 45. So actually, I can now say that y is equal to a... Oh, no, I know my y value. Stop. I know that y is minus 45. X is 0, so that becomes plus 5. X is 0, that becomes minus 3. Minus 45 is equal to a. Minus 3 times 5 is minus 15. That would suggest that my a value is 3. And I'd have to form it. What does the question want me to do? Well, I never finished it off, so I would imagine it wants me to actually write it formally. So I'd have y is equal to 3, x plus 5, x minus 3. What were my thought process here? Again, that's the important thing. I looked at this and I looked at those equations. I looked at these this information here, and I was like, what are they trying to tell me? Well, firstly, they're trying to trick me with this first section. So I wrote it out longhand. I realized they were coordinates. I wrote out my coordinates. Now, even if I hadn't twigged straight away that it was intercept, I probably would have drawn a graph and gone, okay, well, I've got 0 minus 45, so there's minus 45. I've got 3 zeros, so there's 3 0, and I've got minus 5 zeros, so there's minus 5. Probably, and hopefully, once I'd drawn that and even sketched, I'd have gone, yo, hold on a moment, those are the roots of my equation, and hopefully my brain would have actually given me this equation here. All right, that's it. That's enough for this particular section. Thank you very much for listening. Hopefully, you now have some information to help you apply function notation. Thanks very much. I look forward to seeing you on the next video. It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So, if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right? Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. All right, well, you have an awesome day, and I look forward to seeing you again.